So let us start with another easy problem. So the question simply says that I have given you an integer n and another integer k. Okay, these are the two inputs that are provided to you. Okay, now the question says what you are supposed to do is you are supposed to print all the unique combinations of k numbers. You are supposed to print all the unique combinations of k numbers where any number is in between 1 to n. Okay, so this n as an input says that the numbers from which you can choose anything is from 1 to n. Okay, and of course you can choose a number only one time. Okay, choose any number x from this at max one time. Okay, so you have to talk about that how many combinations of k numbers, how many unique combinations of k numbers can be generated if you are supposed to pick any number from 1 to n. So let's say n is equal to 4 and k is equal to 2. Can somebody tell me how many combinations can be there? N is equal to 4 and k is equal to 2. So how many distinct combinations will be there? Okay, so what is the meaning of n equals to 4? Which all numbers you have with yourself? You have numbers 1, 2, 3 and 4, correct? Now I want you to print me all the unique combinations in which there are two numbers only, okay? And those two numbers must be chosen from this. How many combinations of k values do you see? Okay, you say 4 into 3. So when you say 4 into 3, you mean to say that if let's say I'm supposed to pick two numbers, the number of choices that I have for one number is 4 choices, and for second I have got 3 choices. So 4 into 3 should be 12. But this will lead to repetition. Why repetition? Because after having picked a combination like 1, 2, you will also end up picking a combination like 2, 1, isn't it? So this is what I don't want. Okay, I don't want this kind of repetition to happen. And yeah, so yeah, you understand that I don't want this kind of repetition. Like I had shown you a combination, the first question that we had done in the last class. If there is a combination like 1, 2, 3, I don't want 2, 1, 3 to come again, right? Because that is actually a repetition of it. So yeah, so now tell me, then how many combinations will be there now? How many combinations of two numbers can be there now? I think it is very, very easy to guess. So 1 with 2, 1 with 3 and 1 with 4. Will you have 2, 1? No, because 2, 1 is same as 1, 2, but you can have 2, 3. Similarly 2, 4 and finally 3, 4. So these are the 6 combinations. Now had the input been k equals to 3. So for k equals to 3 again you would have got many combinations. I can write any one. So let's say 2, 3, 4 can be one of them. If you're having 2, 3, 4, please don't have 3, 4, 2 again. Something like that. Okay, cool. So guys, I think the easiest way in which maybe I can solve this problem is, this is just like, you know, variation of the problem that asked me to print all the subsets of a set, right? So I can imagine a set that contains numbers from 1 to n, okay? That contains numbers from 1 to n. And now what I can simply do is I can invoke my algorithm to generate all the subsets of this set, because this is a set, right? So I can invoke my algorithm to generate all the subsets of this set. Now whenever I am printing a particular set, then I'll just check whether the size of that set is equal to k or not. Only if the size of that set is equal to k, which I am printing, then I'll include it in my answer. Otherwise I will not include it in my answer. Cool. So this is one way to do it. But if you think a bit deeply, the question doesn't give you an array. Question simply gives you n, and question conveys you this thing. So if you have been given n and you have been conveyed this thing, do you actually need to build this set for yourself to solve the problem? because if you do that, you are unnecessarily using order n space, right, to build that array. Guys, others, are you getting the point what I'm trying to say? Yeah, so a single variable can be enough, right? A single variable can be enough. Are you getting it, guys? The single variable can be enough or not? You can just have a variable as I, and I, so let's say the initial value of I will be 1, and whenever you are at I, then you are not talking about array of I, because array of I is equal to I, okay? So you don't need array of I. So whenever you are at I, you can either take it or not take it. Irrespective of whether you take it or don't take it, you will move on to I plus 1. And that is how your job can very easily get done. So if I talk more about this, I can say something like this. It's just like, see, since you're supposed to print all the subsets of size k, all the subsets which are of size k, all the unique ones, so you would definitely need a temporary array for that. So let's say I have created a temporary array for that. Can you tell me what should be the size of that temporary array? It should be equal to k, because it will never contain more than k elements, because all the combinations that I am supposed to print according to the question should be containing exactly k elements in them, okay, nothing less, nothing more. So I can start with an empty temporary array, and then I'll have that value k which is given to me. So I'm writing that k over here itself, k equals to 2, and then I'll track its size, okay, so I can track its size using another variable which is 0, and then which element I have to consider, for that I'll use I, and the initial value of I will be equal to 1, okay. So 1 basically denotes this. Now I have two options, so either I can take it or I can not take it. So if I wish to take it, then I'll have 1 with me, and then my size will grow to 1. And now, so whenever you come down, that means why you are coming down, because you have decided for this element, either you said yes or you said no. Irrespective of whatever you said, you will move on to the next element, which is 2. Now here also you said no, that means it would have remained as it is, the size also as it is, but you would have moved on to 2. So this is how you would have gone on and on. And now again, when you have a 2 with you over here, okay, then again you have got two choices, either take it or don't take it. If you take this 2, you have 1 2 with you, and now the size of this becomes 2, and now you move on to 3. And if you say a no, this would remain as it is, and you have a 1 with you, and you would move on to 3. So this is how the recursion tree would grow. Now can somebody talk about the termination condition for this example? What should be my termination condition over here? Yeah, so whenever count becomes equals to k, like here I saw that my count has become equals to k. So is there any utility to go down from here whenever the count has become equals to k? No, right? Because if you go down from there, you will end up getting a subset which will contain 1 2 and some more elements, but you do not want more elements, you wanted exactly 2 elements. So you can just stop then and there, and you can simply include it in your answer set, okay. Cool. Now one thing that we have to be very careful about is that here the path was yes yes, so that is the reason if I number these levels as level 0 of recursion, level 1 of recursion, level 2 of recursion, so my termination condition here was found at level 2 only. But do you think that all the termination conditions would be found at level 2 only? Do you think so? No. Why? Here I found it because it was yes yes, okay. What if I might end up having something like no no, then again no, and then again yes, and then again no, and then again yes. So here 2 yes have been encountered at this level, all others were no. So here the termination condition would be over here. So do you realize one thing over here, that this particular approach where I am willing to terminate as soon as I have seen 2 elements in my temporary array is more efficient than the previous approach where you were terminating always at the last level. So in the original question, the former question of finding all the subsets of a set, you always used to terminate at the last level where the index value of the array became equal to n. But here you can terminate early. So you know, this kind of, I wanted to take this problem because I wanted to talk about a technique which comes very handy, and this is a very simple example to learn that is called as pruning. Okay, and we'll all learn in detail about what pruning is. So this pruning has come from the word called prune. Can anyone tell me what is the literal meaning of prune? It is a simple English word. What does it mean in dictionary? What does it mean to prune something? Prune doesn't mean terminate. Terminate is when you stop. Prune means to cut. Yes, very good. Prune means to cut. So by pruning I mean to say that, hey, what you could have done is you could have allowed it to grow. Instead of taking temporary array of size k, you could have taken temporary array of size n, and you could have allowed it to grow on and on, and then you could have terminated just at the last nodes. And you could have taken only those temporary arrays, only those subsets for which the value of size was equal to k, and you could have discarded others. Okay, this is also how you could have done it, but here you pruned it. Pruning means cutting a part of this tree. So you cut this part of the tree from the original tree itself. So whenever you prune, then you actually end up improving your algorithmic complexity, because a lot many function calls that you could have made otherwise, that too uselessly, you can actually prevent making them up. Because when the tree is getting created, it is getting created exponentially. One node gives rise to 2 nodes, those 2 nodes give rise to 4 nodes, those 4 nodes give rise to 8 nodes. So whenever you prune at a particular let's say high level, that means there is a lot of jungle that could have germinated below, and you have actually gotten rid of it. So it is a good idea to prune to improve the complexity by certain amount. Yeah, so this is a very helpful technique, and in certain problems, you know, knowing this technique is very good because your code can be much better than other. The order of the complexity might remain the same, but the number of operations will be drastically reduced. Okay, so the first question that somebody is saying is that the termination condition that I should have is that should be at the level of size. So whenever size has become equals to k, you simply enter this in your answer. Okay, and what is your answer? Your answer will be a vector of vectors. Okay, so your answer will be a vector of integers, and this answer, if let's say you are passing it in function call, how would you want to pass it? Would you want to pass it by value or pass it by reference? You would want to pass it by reference, and you would have seen that. So because that is to be shared across all functions, you want that if a particular function node has inserted something in this, then that insertion should not get lost by the time I reach here. Okay, those answers should be contained over here, here as well. Okay, so I would want to pass it by reference. Yeah, another thing that I was saying was yeah, that my termination condition should be whenever size is equal to k, then terminate. Do you think another termination condition would also be required? So one of you asked about it. Should this just be my only one termination condition, or should I have some other termination condition also in my code? Okay, so let us take an example that is very much required. Why? Because don't you believe there will be a branch which will say no, 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 and then eventually the value of this would have become n. So do you believe that such a kind of branch can be there or not, which completely says no, 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 right? That branch will be there. In that branch, by the time your 1 grew from 1 to n, what would have been the value of k? What would have been the value of k along that branch? It would have continued to be 0. So won't you want to terminate there? You would want to terminate over there also. Is that clear to everyone? Just say yes, those of you are getting it. Yes, so this should also be one of your termination condition. So apart from this termination condition, I should have one more termination condition, that if my this particular thing, let's say this was I, if this I has become equals to not n but more than n, if it has become, let's say, greater than n, then you can simply return from there. Why not n? Because at the level of n also it could happen that this thing became k equals to 2. If it was a no, 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 and at last there was a yes, there were two yes, then it would have become 2. So whenever you see that the value of I has become greater than n, then you can simply prefer to return from there. So when you write the code, ensure that you have all these termination conditions. So you will realize that when you are actually writing the code, there is a termination condition which is favorable to you, which is actually giving you the right kind of answers, but never let go of other kind of termination condition, because if you let go of that, then you will end up having an infinite recursive call, because k will never become 2 along that branch, and n will keep on growing and growing and growing, and then there is no termination to it. Okay, so let me do one thing. For those of you who might be having some trouble writing code, I will try to write a code and learn from here. Okay, so learn from here that how can I write a recursive code in a very clean manner, which can be debugged also very easily and which can be understood also very easily. So before writing recursive code, what is the most important thing that I should decide? First, I should decide how these recurrences are going to happen. So that is called as recurrence relation. How a function is going to call other functions. How many transitions can be there? So here there are 2 transitions, but it is not necessary that always you will have 2 transitions. Sometimes you can have 3, 4, 5, many transitions, and sometimes you can have variable number of transitions. What I mean by that is, at this node you had 2 transitions, but at this node you might just have 1 transition. Now at next node you might have 10 transitions. That is quite possible, and we'll see such examples. Okay, important thing to understand over here is I should be able to decide that how many transitions will be there and how are these variables going to change with those transitions. Next important thing is, what are my termination conditions? Okay, so let me just write those. So if let's say there is an initial function which asks me to return vector of vectors of integer, and this function is called combine. So it takes in input n, it takes in input k, okay, and it wants me to return this vector of vector answer. Okay, so let's say I'm going to now write the code. So first thing that I'll do is I'll create my answer, which will be my vector of vector. This is my answer. Okay, now first talk to me about edge cases. Are there certain edge cases that I should handle? Because nothing has been told to you about n and k. Nothing has been told to you about n and k. So don't you believe I need to cater to some termination conditions? Yes, if k is greater than n, then is there any possibility of having subset? No, right? So in that case you should return empty answer. Similarly, if k is equal to 0, then also empty answer. Okay, so you can have a condition that if you see that k was greater than n or k was equal to 0, just return this empty vector itself. So just return answer. So this is the first thing that you should do before making your recursive call. If you see there is some edge condition that you can handle very easily, handle it here. You can handle there also, you can handle it in your recursive function also, but if that is very trivial and if you have caught it beforehand and you want to handle it in your function itself, you can handle it. It's a good practice itself. Okay, cool. Yeah, now for the other cases you would want to invoke a function which does the job for you. Okay, so let's say there is function called get combinations. So this is going to be my actual function where all this entire magic is going to happen over here. Okay, so yeah, so I need to write this function. Can somebody tell me, is it necessary to have this a return type? Is it required for this to have a return type? No, I can make it void. Okay, why? Because I am passing the answer by reference. So in the termination condition it can simply populate that answer vector and again pass it by reference. Okay, so I can simply have it as void. Very good. Cool. What is the next decision that I have to take? Next decision that I should be taking is what should be the parameters that it should be taking. Okay, So take a look at whatever you have drawn. So tell me what all are the things that you would want to pass to it. So first thing, this answer is a must to pass, isn't it? And I must pass it by value or reference. I must pass it by reference. Okay, so I'll pass this answer. Anything else that you feel I should pass? So I need a temporary array, okay, where the numbers are being stored however they are. So I need to pass that temporary array also. But before passing that, I need to declare it over here. So I will declare it, this temporary array. What should be the size of it? It should be, its size should be k, because it will never have more than k elements in it. Okay, cool. Once I have declared it, then I can easily pass it over there. So how should I pass it? This is a this is an array. So this array is to be passed by reference or to be passed by value? It should be passed by reference, correct? Why? Because that is how it happens, right? Whenever you move on to a new function node, then you do not create a new array from there. You simply pass the array by reference and insert a new element in it. Getting it? Are you getting the point? Right? This is very important to understand. So you will be passing it by reference, and this is the way to pass it by reference. Another thing, I need to track the size of it. Tracking the size of it will allow me to insert at the right index position. So let's say that size is captured in a variable called j. Okay. Apart from it, for my termination condition, I need this k. So I'll want to pass this k also. Okay. Anything else apart from j and k? Anything else that I need to pass? Do I need to pass n also? Because n is also one of my termination conditions, right? So I need to pass n also. So let me pass that n. Anything else that I need to pass? I need to pass another variable called I, where I is the element that I will prefer to include or exclude. Guys, yes, no? Right? Yeah, I is not index, I is element itself. Okay, I is element itself, where I varies from 1 to n. Okay. Okay, after declaring this thing, now I would want to make a call to this. So I'll call get combinations and I'll pass everything. So I'll pass my answer, I'll pass my initial vector. What should be the value of j? J denotes the size of this temp. So initially the temp is empty, so j should be 0. K should be as it is, whatever is k, you pass that. What should be the value of I? What should be the initial value of I that you will pass? I should be equal to 1. Okay. And what should be the value of n? It should be n itself. Okay. Cool. So, and then you call this and then it will do its job, and finally you will return the answer. This answer has been well populated by this method. So now come at this method. So what is it that I should write first in this method? What is it that you first write in your recursive code? You write your termination conditions. How many termination conditions were there? There were 2 termination conditions. So first termination condition was whenever my size of the array, which is stored in j, became equal to k. So if at any point of time I see j becoming equal to k, then what is it that I am supposed to do? Then this is an array which contains my subset, but this answer is a vector of vectors. So you cannot push an array in vector of vectors, but what you can simply do is you can translate this. So you can copy the elements of this in another vector, and then this vector can be pushed in the answer. You can perform answer.push this particular vector that you have created out of this temporary array. And after having done this, then you can simply return. It is important to put a return also over there. If you don't put a return, then you will have to write else condition, right? Okay, so after this, I have another termination condition also. What is another termination condition? When my I becomes greater than n, right? So if my I becomes greater than n, what should I do? Is that a termination condition or not? Yes, that is, right? So in this case also, I should simply return, right? I should simply return, right? Because why did I become greater than n? If you skipped this, if let's say this condition was false and you came over here, that means there was a branch like this where you could not gather k elements, and you ran out of elements. Okay, that is the reason your I became greater than n. So you should basically discard and you should simply return over there. Okay. Apart from this, if I was neither here nor here, what does it mean? That I am at some terminal node where I need to make the two choices which are possible, isn't it? So if you could not touch upon those two termination conditions, that means you are at a terminal node. So whenever you are at terminal node, how many choices do you have? You have got two choices with you, right? So let us execute first choice, which is yes. So what is the meaning of yes? Yes means that you want to include this element, which is I, in your temporary array, right? At which index? So if you are doing the work for yes transition first, so you would say temp of some index should become equal to I. What should this index be? It should be equal to j, because j denotes the size of temporary array. Okay, very good. After doing this, you would want to make the recursive call. So you took an element and then you make the recursive call. So when you make the recursive call, you will call this getComb again and you will pass this answer, okay, as it is. Okay, this is anyways passed by reference, and you will pass this modified temporary array. What will be the value of j? Because you have considered inclusion of a new element, so the value of j will become j plus 1. K will remain as it is. Since you are done with ith element, so you will move on to I plus 1th element, and n will also remain as it is. Is it clear to everyone how the parameters have changed and why they have changed, right? So for some of you, I saw in the code you were not doing it properly. So the only reason you are not doing it properly because you are not crystal clear that what is the meaning of these things and how are they changing over here. Because if this diagram is clear, then this is just a piece of cake. Okay. Okay, what should be done for no transition? No transition, what does it mean? No transition means that you do not want to include a new element. If you do not want to include a new element, will you want to do j equals to j plus 1? Will you want to move on to the next value of j? No, right? You would keep j as it is so that it can be overridden by some other value. So you can call this again, answer will be as it is, temp will be as it is, j will be as it is, k will be as it is, and what about I? Will I change or not? Yes, it will change, because whether you take an element or do not take it, you always move on to the next element, which is I plus 1. That's it, just this much of code and your job is done. So if you plan really correctly about your recurrences, termination conditions, parameters, how they are changing, then it's just nothing.